Welcome back. How would we run our project in production? We can run our server and client with one command now. But they still run separately as different applications on different ports. Our server runs on port 8000, while our client uses port 3000. When we run our project in production, to keep things simple, we often want to run the entire thing on one server, somewhere in the cloud. Ideally, we'd have the ability to serve our front end from the same server as our API. This way, we'd not have to manage two separate servers at different URLs or with different ports. The way we usually do this is in our client. If we're using some framework like React or Angular, like React, we'd first build our project, including our framework, our source code, and any assets that we're using, into a single build folder that's optimized for production. So with our client here, if we look in package.json, we have this build script. What does it do? What happens if we try to run this? Let's see. Right now, it's only in our client's package.json, so we need to cd into our client and run npm build. Our script is creating an optimized production build from our source code. We now have this build folder with all of the assets needed for our application. And our source code has been bundled into these strangely named files here, which have been compressed to minimize load time. We can learn a lot more about what Create React App does when it builds our script by going to this link, cra.link/deployment. Here we can read all about what this build script does and how it lets us serve our site directly from index.html. There's even some information here about different types of routing, as well as how to deploy our application using different clouds, like AWS Amplify and Azure, Google's Firebase, and so on. No worries, we'll dive deep into deploying Node projects in production using the cloud. We'll get there. For now, this page is, of course, React specific, but most frameworks provide a script that allows us to build our application for production. And if you're using just plain old JavaScript for your front end, you don't even need to worry about this. You can just serve those files directly. Let's get this working with our project. We now have this build folder, and we want to serve it from our API. We don't want this build to stay in our client, so we can automatically set up our client to copy this folder into our server. We do this by setting this build_path variable in the environment where our build script runs. And we point this using the equal sign to our server directory. So we're going to go up out of our client and into /server. Specifically, we'll be serving the /public folder, which will contain the files from our build, just like these. So we can get rid of these for now. And now, if we run npm run build, our optimized production build will be moved directly to our server, check it out. We have this public folder with our front-end code. Now, this build script, build path variable works on versions of the React scripts package that we've installed here, which are greater than 4.0.2. So make sure you're using the latest version of Create React App and the React script tool. If you're stuck using an older version of Create React App, you can copy the files from the default build folder in the client and move it to the public folder in the server, doing this manually. The build path is just shorthand for doing exactly that. And now our client's code is side by side with our server, optimized for production, and we can serve it from our API. We've done this before. Let's recap. In our app.js, as part of our middleware chain, right below express.json, we'll use another built-in Express middleware. app.use express.static. And here we'll serve all of our public files using the path.join function in our built-in path module. Path equals require path. And we're joining our current directory with, we're currently in the source folder, so we want to go up out of it one level and serve the public folder. We can group all of our Express middleware that's built in, and let's see this in action. We can now go to the root of our project directory, and we don't have to run our client anymore. We can just do npm run server, which, if you remember, runs our watch script. Let's give this a go. Now in our browser, we go to the URL for our API. So localhost at port 3000 is where Create React App would serve our front end, but it's now Express doing the serving and not Create React App. So we go to the URL at port 8000. And it's serving our application in that index.html. So let's try loading it. And we get our front end, but it's not loading the launch endpoint. We need to browse to launch on that first page load. Because remember, our front-end application is only routing the slash and the /launch routes to the launch page. And index.html is not one of those routes. So let's fix this. We're going to serve our index.html from the /route so that the user doesn't need to specify that they want to load index.html, and so that that first page load corresponds to the launch page. So right here, below our planet's router, let's tell Express what to do when we .get the /route. We'll use an arrow function, which takes request and response, and sends the index.html file in response. If we remember, that's the res.send_file function. And we'll use our path.join to join our current directory, where our app.js currently is. And we're going to go one level up out of the source folder and into public/index.html. That's the file we want to serve. So up one level into the public folder, and specifically the index.html file. There we go. Let's run our marvelous little API. And in our browser, let's try loading the root route. There we go. No need to load index.html. And we can browse to our different routes. All right, so that build process was a little bit tedious. Using our newfound npm scripting mastery, let's go to our root package.json here, and we'll create a script, one script to rule them all, that builds our client and runs our production-ready server. So let's call this deploy, because we'll be using it in production. And we can say npm run build in the client. So that's going to be prefix client. And once that's done building and copying the public folder into our server, we can then just do npm start in the prefix server folder, which is going to run node directly and not nodemon, which is more of a development tool. Remember, nodemon is our development dependency in our package.json right here. So now, by running npm run deploy in the root of our project, we can serve an optimized build of our front-end code using Express's static file serving functionality, all using one server with one port. npm run deploy. And once our server starts listening, in our browser, everything is available. Very nice. I'll see you in the next video. Welcome back. Now that our server is taking in different types of requests, we want to be aware what those requests are in our logs so that we can see whether things are working correctly or not. We could write our own middleware to log requests using the request.method and request.url properties that Express makes available to us. But there's a much more convenient way that supports a lot more functionality. That's right, you guessed it, there's existing middleware that we can use to save ourselves some work and give us some really professional logging functionality. Poking around in our trusty npm registry, we can find the most reliable logging middleware around, which is this Morgan middleware. Let's see what it can do for us. Morgan supports a lot of advanced functionality that allows us to redirect our logs to various different streams. Streams like, for example, files or some log service on the internet. We can use Morgan's integration with Node's built-in stream functionality to do what's called log rotation, where we send our logs to a new file every day or every hour. In large-scale production servers, log files often get huge because we're taking in hundreds of requests per second. And we fill up the hard disk on our server machines with these logs. You won't believe the amount of times I've investigated a server that's stopped responding, and it's because the hard disk is full. Logs are great, but they can be dangerous. So Morgan does a lot of useful things for us. It also allows us to define what data we want the logs to include, like the current date or the HTTP method of the request. we can specify how to format the data that is logged. But it also supports a few different predefined formats, which meet our needs very nicely. The most common format is combined, which corresponds to the log format used by the well-known Apache web server, using its so-called combined logs format. This is a lot more complete than any middleware that we'd write ourselves. It includes the HTTP method, the URL, and also the user agent, containing information about what browser made that incoming request. All right, I think it's fair to say that Morgan is awesome. Let's add it to our backend. First thing, we have to npm install Morgan. It's not a development dependency. And now that it's installed, let's add it to our fancy middleware chain. Where should our logging middleware go? Definitely somewhere high up. After all, we want to include the files that we're serving statically, as well as any API requests. So it should go as high as we can go before any security-related middleware that controls what comes in and out of our server. And the only security-related feature we have right now is CORS. So let's add it right below where we manage our cross-origin requests by saying app.use, and we need to import Morgan. So it's going to be Morgan. And we're going to call the function that we get back from the Morgan module. So Morgan, which takes in a string that tells Morgan which of the predefined formats we should use for our logs. So it defaults to combined, which is the most complete one. So let's use that. But I'm going to include it as a parameter just to be really explicit about which format we're using. And we now know we can change it to, for example, the common format, also used by Apache, or maybe a much more short and brief log format for development. We know we have the option to pick and choose. So let's say combined, and we're good to go. Now, if we start our server, either by running npm run watch, let's give that a try. That runs both our client and server in watch mode for when we're developing our application. And let's just browse to and from a few different pages here. We can see that only one request was made. So our front end is optimized to only get the planets the first time the page loads. And we have all kinds of useful information here. We have which origin is hosting our site, and which browser I'm using to make requests against our API. We can see that it's Chrome on a Macintosh. So that's in development mode, where our front end and back end are being served from two separate applications. We're only logging what's coming into the server. So what happens if I exit out of this and run the production variant, where our front end is served from our API as well? npm run deploy, which will build our front end and serve it from port 8000. Now we can go back and let's refresh. And this time we need to make sure that we're requesting the version from port 8000. And there we have it. Let's make a few requests. So navigating to all of our different pages. And let's see what was logged in our server. We now have all of these front-end requests for the different files, like our background image and the fav icon. These are mixed in with the API requests. If we can find the planets request somewhere here, there it is. Both our front-end and back-end requests are coming in through port 8000. And our logs are looking more active than ever, which means we have a clearer picture of what's going on when our users are browsing our application. And with that, I'll see you in the next video. Welcome back. It's always more fun implementing new functionality and new endpoints. Let's have some fun. So far, we've built an endpoint for our planets collection, which gets a list of potentially habitable destination exoplanets. But what about our launches? These upcoming and historical missions that are tracked by our NASA Mission Control application. It makes sense for us to start by thinking about what collections we need and what models those collections would require. Just like we had a planets model, it makes sense for us to have a launches model, which we add to as we schedule new launches. And this will correspond to our launches collection with a launches router and controller. Let's start with our launch model. I'll start by creating launches. We're keeping our naming plural here, .model.js. What are we going to be keeping track of in this model? We can start by looking at what functionality our UI will require, this front end that we have over here. So page by page, we know that in our launch page, we need to schedule a launch date, which might correspond well with a JavaScript date object. We also need a mission name. That's a string like hello Kepler exoplanets, whatever we want to call that mission. A rocket type, also a string. One of these destination exoplanets, which we refer to by name. And we know that when we submit that mission, when we launch that mission, it's going to get scheduled for launch on the date we selected. So that's when we're going to add it to our launches collection in our API. But hold on, let's not forget about our two other pages. So in upcoming, we can see the list of data that we store for each of our launches. We have this number that corresponds to the flight number for that mission. This is a new piece of data. Then we have the date, the mission name, and the rocket, like we just saw, as well as that destination exoplanet. So far, so good. What about our history page? It stores a similar set of data with the addition of this customers column. Each of our missions is funded by, and each of our missions carries a series of payloads, these machines and satellites that are going to be used in outer space by our customers, by our organizations that are funding these missions. These can be things like NASA themselves. Maybe it's the military, or a university, or even organizations like the National Oceanic and Atmospheric Administration, NOAA. which can do some really cool research predicting how events happening in our solar system and outer space affect our weather here on Earth. And that's just one of the ways that we can use these satellites to advance scientific research. So each of our launches will track one or more customers that are making use of that launch for their purposes. Let's put what we've just discovered in writing into some pseudocode that we can use as a starting point to design and build our launches model. Say we want to store our launch in an object. So we'll say const launch, and then this launch will store a series of properties and values. Let's use this to build out an example launch. We'll start with the mission or mission name, which can be something like Kepler Exploration X. And we'll also have that rocket name, which we saw could be something like Explorer IS-1. We also had the launch date, which is some day in the future that we can track as a JavaScript date object. So we'll construct a new date, and our launch is going to be, say, on the birth date of Johannes Kepler, who the Kepler Space Telescope was named after. So December 27th, and we'll schedule our launch for the year 2030, with its destination being, say, Kepler-442b, my absolute favorite exoplanet. We'll also keep track of the official flight number for this launch, a sequential number which tells us which launch this is, which can act as a unique identifier for this mission. We'll call this our flight number, and we can say that it starts at 100 and goes up from there, one by one. Next up, we have our list of customers. So this can be an array which contains the names as strings. So maybe it's NASA and Zero to Mastery, both as customers for Kepler Exploration X. Now, we also need a way of differentiating between upcoming and historical launches. We could check this date and see whether it's in the future or not, and use that as a metric for whether our launch is upcoming. But we could have launches that are scheduled for future dates, which are aborted. Remember, in our upcoming list, we could click this X button to abort a mission, which means it probably makes sense to track whether a mission is upcoming or not as its own Boolean variable. We'll say upcoming starts off as true and only becomes false once this launch becomes a historical launch. And finally, these missions aren't always going to go according to plan. We need to prepare for all eventualities. So at the very least, for historical missions that have already launched or failed or been aborted, we'll keep track of this success variable, which is also a Boolean. Now we're optimists, so let's start off with success being true by default. We have a pretty good collection of data that we now need to track. So how do we add a launch to our launches collection? We could have a launches array which starts off empty, but we'll use an even better JavaScript data structure. We're going to make use of the JavaScript map object. This works a lot like a plain old JavaScript object, where we map string keys to values. Flight number is our string implicitly. We could also say flight number, and 100 is our numerical value. The difference with maps is that they allow us to map any value to any other value. For example, we could map numbers to objects like dates or strings, and if we're really being crazy, we could even map functions to values in our map as well. They're a lot more flexible than our JavaScript objects. And they also have this really great feature where they preserve the order you insert things. You always get back values in the order you put them in, which is not guaranteed when you're going through the keys of an object. To make a map, we call our new keyword to construct a new map object. We can now add launches to our launches map by calling the launches.set function and passing in a key and a value. Notice that they can both be any value, any type. Simple keys and values are easy to work with, but it depends how crazy we want to get. For us, we'll be indexing our launches. That is, we'll be searching through them and accessing them by the flight number. The flight number makes a natural ID that's unique for each of our launches. So our map is going to map flight numbers to launch data. And the way we do that is by passing in launch.flightNumber as the key and the launch itself as the value. We could now access our launches by calling the launches.get function and passing in our key, our flight number, for example, 100. This would return our launch object. But instead of doing that, we're going to export our launches map from our model so that we can use it in the rest of our code. So we'll say module.exports an object that contains the launches. For now, just the one launch in our example here. We're all set to build our launches router and expose our launches model to our front end using our Express API. Let's keep going in the next video. I'll see you soon. Welcome back. We've gone through all of the hard work of building out our launches model and figuring out the requirements of what data we need to collect. With all of that out of the way, here's my favorite part. We get to add a new router into our application. In our case, it looks like our front end will be accessing the launches in the upcoming and history pages. So the routes that we build for the launches correspond one-to-one with our launches model. We won't need to access, for example, the planets model in our launches router. This won't always be the case, which is why we still have our models and routes separated. But in this case, it really makes sense because we'll be accessing our launches model directly in our launches routes. So what we're going to want is to have a launches router just like our planets router. And we're going to create a new folder /launches for our launches routes. So let's create that folder. And this part is pretty much always the same. We build a corresponding launches.router.js and a launches.controller.js. In our app.js, we'll be app.using our launches router together with our planets router. They'll be matching against different routes under different paths, so it doesn't matter which order we put them in relative to each other. The important part is that in our launches router, we set up our endpoints very much like we did in the planets router. To recap, we need access to the Express framework because we'll be making use of its built-in Express router. So require Express. We define our launches router to be an express.router object, which we can then define routes on. For example, launches router dot get, and our first endpoint will get all of our launches. Calling some function we call getAllLaunches. Our friend module.exports can now take in our launches router directly so that we can use it in app.js. What about our controller? How do we bridge the model that we've built with the router that we've just written? We have this sandwich of a router that's ready to go and a model that's ready to go, but the inside, the controller, is blank. So let's make it something light but juicy. It's going to be a function that we've already decided is called getAllLaunches, and we take in that request and response. This function is going to make use of our launches model, which we can require by looking in the current folder. No, that's not right. We need to go up one level out of our launches folder, and then up one more level out of the routes folder into models/launches.model. And specifically, we're going to be making use of this launches map. So let's destructure that, launches, from our launches model. And when we return from our controller, we'll be setting the response to give us this 200 status code and to return JSON that corresponds to our launches map. Unfortunately for us, these map objects that we have in our model aren't JavaScript object notation. Luckily, we have a solution. What we really want to return from our getAllLaunches endpoint is the list of values in our launches map. All of these launch objects that we set using our set function. And we can get these values by calling the values function on the map object. So our launches map.values gives us this iterable iterator of values in the map, where we could, for example, use a for of statement and say for value of launches.values and then do something with each of those values, where we can also set the value as a constant. And this would allow us to loop over all of the values in our launches map. But that's not quite what we want to do. We can't turn this iterator into something that the JSON function returns directly, but instead we need to first convert it into plain old JavaScript object or an array, which is also valid JSON. The good news is there's a function that helps us do this. In the built-in array object, we have the from method, which takes this iterable returned by launches.values and turns it into an array containing all of those values. Notice how our controller here is taking the data as it lives in the model, which allows us to index into our launches by flight number and store all of our data efficiently in a map. But then our controller manipulates that data into a format that works for our API, into JSON that we can return back to the front end. We're ready to export our function and see if everything works. Module.export equals get all launches. Let's make sure our router is using the correct function. And wait a second, VS Code has automatically imported our launches model here, but instead we should be importing our controller. So let me do a destructuring of our get all launches function from the exports in our current folder /launches.controller. That hooks up our controller and our router, exports the router, and then in our app.js, the launches router takes care of requests matching the /launches get endpoint. Looks good to me. Let's give this a go in Postman. In the terminal, let me do npm run server. And now in Postman, let's test our NASA project. So we can create a new collection for that project. I'll create it. And now inside of our NASA project, let's add a request called get/launches, save it to our NASA project, and this is going to match the route we just added at http://localhost at port 8000/launches. We'll save that, and let's see if our endpoint is working. Amazing! We're getting our JSON response with our array of launch data. Let's make sure that Postman can request our planets collection as well. We'll add a request calling it get/planets, and this time the URL will be localhost at port 8000/planets. And this is a GET request. Everything's looking good. But will our front end handle the data we're passing it correctly? Back in VS Code, let's terminate our server and this time run npm run deploy. Let's see if the production version of our NASA application is working as expected. It should, because if we go into our client-side code under source, pages, and launch, which is the component that we're showing when, let me close the terminal for now. We browse to the /launch page, the launch component is shown. And when we go to the /upcoming page, the upcoming component is shown. And these components take in the launches data that we've fetched from the API and display the different properties for our launch. For example, the flight number, the launch date, and so on and so on. The properties match up with what we saw returned from the API in Postman. And if we go to the history, we can see that the upcoming launches are filtered out using our filter function. We show this block character in greenish yellow if the launch was a success, and in red if the launch failed. And we also join the customers array and all of its customers with this comma if the customers array exists. What remains is for us to add a way of requesting the launch endpoint from our front end, which is going to be in our requests.js under hooks. This getLaunches function that's called in our useLaunches.js file over here is going to use the built-in browser fetch function and convert the response to JSON. So let's remove this to-do comment and move our description just out of the function. And here we'll do const response equals, just like with our getPlanets function, await fetch. We're talking to our API with the API URL, and we're making a GET request against the launches collection. Just like before, we'll get the response.json to parse our results, and we'll await for that promise to complete. Now, our front end is also asking that our flights, our launches, are sorted by the flight number. We can do operations like sorting both on the back end, but also on the front end. And sometimes for things like validation, we'll do it on both, just to be extra sure. So let's assign the JSON to this fetched launches constant, and then we'll return fetched launches, but sorted in ascending order by the flight number. So this will use the .sort function on our launches array, and we can sort by passing in this callback with a compare function that takes two values from our fetched launches and compares them, returning a negative value if the first argument is less than the second argument. What this will look like for us is we'll take in two launches, A and B, and in the callback, we'll return the first launch, A.flight number, minus the second launch, B.flight number. Now, if B has a flight number that's greater than A's flight number, well, a smaller number minus a larger number will give us a negative result, which means our sort function will give us our launches in ascending order by flight number. Our front end is making the correct request, and things are looking promising. Let's give our server at port 8000 a try. We've updated the front-end code, so we'll need to redeploy, back in our browser, we're browsing our history page on port 8000. So let's refresh our server. And wait a second, it's telling us that we can't get the /history endpoint. What's going on here? And how do we make this work? The good news is we can fix this with just one additional character in our code. We've done such a good job in this video, so let's take a really quick pause and find out what that one character that solves all of our problems will be. I'll see you in the next video. Welcome back. When we navigate to the /history page at port 8000 on localhost, our production build, where we serve our API and frontend from the same server, gives us this error telling us we can't get the /history endpoint. What exactly is going on here? If we go into our code under app.js, we're currently serving all of our assets under the public folder that have been built in the client when we run the build script using npm run build in the client's package.json. This is so that in our server, we can have the front end and the API both available on the same ports through Express. The issue is that our server is handling the routing for our API endpoints, but not the routing in our client. If we go to the client folder under source and under pages/app-layout.js, remember we have our routes for the front end being handled by React. Our React router is also partially responsible for deciding what to do with that path, that URL that we put into the browser. And this is all happening in this index.js file that's being served from our public folder that contains the running React application and all of its front-end JavaScript. Okay, so that's quite a confusing chain of things going on. Why are we getting this error? How does everything fit together? If we go to the Create React App documentation under Deployment, remember this page that told us about the build script? There's another section here. If we scroll down below other solutions to serving applications with client-side routing, that's the kind of routing that we're doing in React. This page tells us that our Express server is trying to find the file that's called /history using our static file serving middleware. And if that doesn't match, it tries to find the /history endpoint in our API, which doesn't exist, right? In our code, our static middleware is going to give us a 404, and neither the planets or the launches router will respond to the /history request. It needs to be the index.html and the React app with our front end that manages that route. So the trick we do is we add this asterisk after the slash in the get endpoint that serves our index.html. This uses Express's matching capabilities, where the asterisk or star matches everything that follows the slash to match basically any endpoint that isn't matched above. And when Express sees one of these paths that don't match any of our routes, it passes it on to our React application at index.html so that React, or whatever our front end is, can handle the routing instead. Our server just sends the index.html like it did before. Let's see this in action. In our terminal, let's reset our server and deploy it again. Now that it's done starting up, let's try getting that /history page one more time. Check it out. Now we can navigate to our pages directly, like upcoming, and React will handle those URLs. And the same would apply to other frameworks like Angular and Vue. Any front end that uses the HTML5 history API for routing, and specifically the push state function to navigate from route to route, can be served from Express in just the way we did in this video. Very good to know when working with full stack applications. All right, I'll see you in the next one. Welcome back. Before we get too deep into implementation, it's worth asking, where do we draw the line between what goes in the model and what goes in the controller? What's a good way of deciding where our functionality should go? This is a common question when working with larger projects that benefit from following patterns like the model view controller in a consistent way. Ideally, we don't want our controllers worrying about how the data in the model from our MVC pattern is stored, whether that be in a database somewhere in the cloud or in memory, like our launches model in our map. Ideally, our controllers can focus on working with the request and the response, and our models can give us these data access functions, which control how the data in the model can be written to and read. Let me show you. Rather than exporting our launches directly, which means that our controller now needs to know that our launches model is a map, which we need to first get the values from and then convert into an array, it would be better to abstract this implementation detail away. What that means is that the controller only needs to know that we're using the launches model, and from that model, we're getting all launches, which is a data access function that we will export from our launches model. And now we have a naming conflict where our controller and our model both have functions of the same name. This happens, and we can deal with it by either being explicit and not destructuring. So we could say launches model and do launches model dot get all launches. Or another pattern that you might see, if you still want to make use of all of the benefits that destructuring gives you, we can be more explicit and call any function that works with our HTTP request and response an HTTP function by saying HTTP get all launches. Now we know that any function starting with HTTP returns a response. And we need to update our exports as well as our app.js, or rather our router.js, to use our newly named function. Now, in our model, we can keep our launches map as an implementation detail that the rest of the world doesn't need to know about. And instead, we'll export some functions, like getAllLaunches, which takes no parameters and returns the launches in the format needed by our controller, converted to an array. Finally, we export our new data access function. It doesn't have to be complicated, but we'll really feel the benefits of this as we write more code. When we use models with these data access functions, there's a clearer division of responsibilities between the model and the controller. Our model only ever works with the data, based on however it's stored. Now compare that with our controller, which only ever uses these data access functions to work with the data model, and to put it all together into a response that's useful for our front-end client. Let's quickly apply this pattern to our planets controller, where we'll use this getAllPlanets function from our planets model, and we'll use HTTP getAllPlanets to access our controller function. So now in our router, we need to make sure that we're always using HTTP getAllPlanets and not the function from the model. Now in the model, we'll create this function, getAllPlanets, which just returns our habitable planets array. And now we can export only our data access and any loading functions from our models without worrying about how the data is stored. Oops, and I think I forgot to call our getAllPlanets function here before we return the result as JSON. I promise we won't be doing too much of this moving of functions around after we get a solid structure for our code. But it's really worth investing in if you plan to keep working on your project for more than a day or two. Definitely, if you're working as a software developer, spending a little bit of time to structure your code is worth the effort. To put what we've learned into perspective, our data access functions are part of what's called a layered architecture, where our applications consist of multiple layers which talk to each other. We can separate our application code into these layers either standalone or in addition with the MVC pattern, where, for example, our data access layer with our data access functions is very closely related with our model. And our business logic will then be the controllers that respond to HTTP requests. And our user interface is like our views. Sometimes it helps to look at our project architecture from the perspective of layers as opposed to models, views, and controllers, and to combine them like we've done with our NASA project. In general, application layers are part of a design principle known as separation of concerns, where we want each part of our project, each module, to be responsible for one thing and to do that one thing well. The more different concerns we mix between modules, the more complicated it is to keep track of all of the changes that are being made and all of the relationships between the different components. Separating our concerns makes our code easier to understand, easier to update, and easier to grow into a much larger, more impressive piece of software. And with that, let's get back to our project. I'll see you in the next one. Welcome back. We're about to implement launch functionality into our API. Let's build our backend to respond accordingly when we're ready to launch our mission. Starting with our chart that tells us the create, read, update, and delete operations that we can perform using our HTTP verbs or methods to create a launch, we're going to be posting to our launches collection. This will let us create a launch that is scheduled for some date in the future. Our endpoint is going to be specific and return a 201 response if the creation of that new launch was successful. And we'll then be able to get that launches collection and see the newly created launch. Sounds good? Let's jump into our code. We can take two approaches here. In our server's source code, we could start at the launches router and work our way through the controller and into the model. Or we could take this bottom-up approach where we start with the most specific details about our model and then build up into the more general controllers and routers. So bottom-up means that we're starting at the base of our functionality, the data model, which is the foundation upon which all of the rest of our functionality is built. Let's start with the launches model. We already have a pretty good idea of what data we need to track. So starting here will give us a lot of clarity on what our controllers and routers will finally need to do. Basically, we need to write a function that our router can use to set our launches in our launches map. So let's create a function, add new launch, and we'll accept a launch as an argument, which will be the launch that we add to our collection, to our map, using the launches.set function, just like we have when we populate our example from when we were testing our getAllLaunches function. So that's a good starting point. Given a launches flight number, which we'll find at this flight number property on our launch object, we want to set the launch at that key based on the flight number to the launch that we're creating. But we want our API to be really friendly to use. It'll be difficult for the client to keep track of what the next flight number for the next possible launch should be. Basically, we want to start at the last flight number and increase it by 1 every time. And the last flight number is a piece of data that lives in the server. So why should the client send it to us when creating new launches, when scheduling those interstellar missions? What we'll do is we'll add some state to our server in this variable, which will say let latest flight number, and that will always be equal to the last flight number that was scheduled. So in our case, we have this one launch with flight number 100, so our latest flight number is exactly that. Now, in our addNewLaunch function, we want to increase the latest flight number by 1, so we can use latest flight number plus equals 1, or just plus plus for short. And now we'll use that latest flight number as the key for our new launch. But we still want to track that flight number in our launch data so that it's returned from our API when we send back all of the values in our map. So if we're saying that this launch won't contain a flight number because it's being set on the server side here, we need to add it to this launch object. So what we'll do is, using the built-in object.assign function, we'll take our launch and we'll assign some additional properties to it. Whatever properties we have on this object that we pass in as the second argument. And if any properties are in both the launch and the new object, the new object will overwrite the old properties in the launch. Let me format this a little bit nicer so you can see what I mean. So we're setting the flight number as the key for this launch that we create in this part of our code right here, which just takes the launch that we got from the user that's getting passed down all the way into our model over here, and we're adding a flight number property that's set to the latest flight number, so that when we get the launches, all of our data is still being tracked. And object.assign will return a new object with the properties from the launch as well as the flight number correctly set. All right, so let's look at our example launch here and think about what the minimal set of data that the client, that the front end, needs to send us to create a new launch. They don't need to send us the flight number. That's something we can calculate. The mission is one of the input fields in our mission control dashboard, so we definitely need to include that. The same applies to our rocket, as well as the scheduled launch date. And we also have the destination exoplanet in our dropdown. But this customer list, well, let's just say that for launches created by our mission control dashboard, our customers are always going to be, let's see, we'll set our customers as 0 to mastery in collaboration with NASA. And more importantly, we know that when we're scheduling a new launch, it's always going to be an upcoming launch, because we restrict our launch date to be sometime in the future. It wouldn't make sense to schedule past launches, right? So we'll also say that upcoming is always true for our new launches until we set it to false once that launch actually happens. And we're optimists, right? So we're going to say that unless something goes wrong, our mission starts off as a success. And we can set it to false if something goes wrong. So now we've saved our client from having to send us all of this data that can be determined on the server side. The user only needs to send us these 4 fields that make our mission unique. Okay, so it looks like our addNewLaunch function is setting the flight number, and then between the data passed in through the API and these extra fields we're setting, everything seems to be covered, so we can export addNewLaunch. Here we go. Before we dive into the controller, let's build an example createNewLaunch request in Postman. By looking at what the user will be sending us, we'll have a better idea of how we need to handle the incoming request. So I'm going to duplicate this getLaunches request, and I'll rename it to post/launches. And of course, we need to change the HTTP method to post. In the body tab here, we'll set our body to raw, and specifically the application/JSON content type. So once we click this, notice that our headers now have content type application/JSON, which means that in our body, we can pass in our launch as a JSON object. What were those 4 fields again? We need to set a mission, which we'll name, say, 0 to mastery 155, and the rocket that we'll be using is going to be this 0 to mastery experimental interstellar rocket, version 1. All right, and we'll be targeting, so the destination for our mission, destination with a T, will be, say, Kepler-186f. And last but very much not least, we need to set the launch date when our experimental rocket will fly off towards Kepler-186. And our date, well, it could take a variety of different formats. We could pass in a number representing the amount of milliseconds since January 1st, 1970. That would be what's called the Unix time format. Or we could pass in a string using any number of formats. Say we're being really explicit and we want to say January 17th, 2030. Dates might sound like a small little detail, but if you've ever worked on some piece of code that does scheduling or works with time zones, you'll know that it's actually one of the most difficult things that we do as software developers. So our controller is going to need to be smart when we handle this launch date. But for now, that looks like a good set of data. So we'll save this, and our goal is going to be for this request to succeed. We'll start by taking a look at the launches controller in the next video. Let's take a short break and keep this one going. I'll see you soon.